Well, good morning, good afternoon, good night, good evening, any other part of the day to everyone, wherever you may be, somewhere across our lovely world today. Well, thanks so much for joining us live here today for the one and only Serverless Office Hours. We are streaming live on the AWS Twitch channel, on the YouTube Serverless LAN channel, and also via LinkedIn Live. My name's Julian Wood. I'm a developer advocate for Serverless at AWS, and I am super happy today to be joined by the one and only Christina Andonov. Welcome to Serverless Office Hours, Christina.
Thank you, Julian. Pleasure to be here.
Well, thanks for coming on and sharing us all your awesome wisdom, which we're going to get to. Now, you're a solutions architect in the AWS Containers organization. Tell us, how have you come to AWS and how have you involved in containers?
Yeah, of course. So I came to AWS it's been probably 9 months to date. And before AWS, I used to work for AWS customers. In the past 5 years, I spent on managing Kubernetes on AWS. And if you think about it, it's 5 years of managing Kubernetes. That was prior to the time EKS existed, when it was hard to manage Kubernetes, when you had to manage the control plane. So I really got to appreciate EKS, and now I'm here helping customers adopt EKS and extend it.
Well, that is super cool. And yes, I mean, some people may be thinking, this is a little bit strange. We're talking about Kubernetes and we're talking about serverless, but I promise you, that's going to be a super good mashup because, containers and serverless work super well together. And what Christina's going to be showing today is super relevant. And I appreciate people are going to be watching, maybe if they're in the Lambda world and they're thinking, hang on, how are we linking this up with Kubernetes? And then people on the Kubernetes world going, hang on, I've got some developers who want to do Lambda. How on earth do these two stick together? So we'll have plenty more information on that. But just before we do get on to that, let's look over what's happened over the past week in the world of serverless on AWS. Last week, we had a stream talking all about step functions, versions, and aliases. And Corey and Shiv says new functionality is step functions where you can basically have versions and aliases to be able to safely deploy your step functions. Lots of great information. Corey was a product manager. Shiv is one of our internal developers on it, and loads of tips and tricks for also using step functions and getting the most out of it. So that's on our Serverless Land YouTube channel, along with all other Serverless Office Hours live streams that we do. So catch up. There's years and years worth of really good content. In terms of what's new coming out of AWS, I'm just going to pick on sort of number 4 down, which is SQS, increased throughput for FIFA high throughput mode. Increased quota. I think it's like 9,000 a second or something. So SQS FIFO always used to be a little bit less, 9,000 messages a second. So if you do need ordering, that is super useful for you. Third one down, if we're talking EKS, in the EKS world, well, EKS does now make it easier to configure and use EFS for persistent file storage. And EFS also now supports up to 55,000 IOPS per file system. In my old infrastructure days, when I was working on SANs and NASs and things like that, 55,000 IOPS was a huge number. Now just available coolly in the cloud. And then also EventBridge. Remember, if you're using EventBridge Scheduler, well, now you can automatically delete those one-off schedules after completion, which is super useful. In terms of some serverless blog posts, if you are a Python developer, number 2 down, then Python 3.11 is now available for use, and Ramesh and Francesco have gone into some of the nuance and the new cool things to do with Python 11. Third one down, if you're using the Go manage runtime for Lambda, we're actually sort of changing things around a bit. And instead of supporting a newer Go version, we're actually encouraging people to use the custom runtime, which uses Amazon Linux 2. All the patching, all the cool stuff that you know and love with Lambda is happening with it. And because it's Go is a compiled binary, just like Rust and some other languages, custom runtime is actually really easy to use. And you actually get a lot more functionality using the custom runtime. So there's really good blog post going on how you can migrate. You need to migrate anyway because Go is on Amazon Linux 1, and that's becoming end of life. So yeah, a few more steps to do, but it's going to be pretty easy to move over. And then just the top one, something I've been involved in quite a bit is Lambda response streaming. And Harold shepherded this post about the Lambda web adapter, which means you can take any web service, just throw it in a Lambda function, and you're able to get those HTTP requests coming in, and the web adapter does the translation, and now you can use response streaming and also loads of tips and tricks. So that's going to be super useful. EDA Day, 26th of October. If you're a music fan, if you're a serverless fan, if you're an event-driven fan, we'd love to see you in Nashville on the 26th of October. EDA Day, all things event-driven architectures. So please sign up. It'll be super cool to get your tickets early, and we'd love to see you there. Our serverlessland.com learning page has been revamped with a whole bunch of learning guides and workshops and all kind of things, and some great new search functionality. So please have a look at that as well. I've actually put a guide on Lambda fundamentals, which is 23 videos of literally getting started with Lambda and serverless from the very beginning. We also have a new distributed data processing with step functions. So whole guide on using the distributed map feature. Really useful. Scale out step functions, scale out Lambda. So much you can do with this. That's really cool. And then also there's a brand new, I think this only came out in the past day or two, the DynamoDB knowledge portal. So everything to do with DynamoDB, really useful stuff, all on Serverless Lab. That's the past week. Let's talk about what we're talking about today. And we're talking about with Christina deploying Lambda with EKS and Crossplane. So Christina, can you just tee us up? I know, as I mentioned before, we've got some Lambda people who may be watching, and we've got some Kubernetes people who may be watching. How does this meet into the middle, and what are we talking about?
Yes. So I do have some slides. Maybe I can switch slides and we can talk on that. I will change my screen to share mine.
My screen's also going weird. I'm trying to get to the right screen. You can see that all going around. There we go. There we go.
All right.
Just before Christina heads off, remember we are live, so send us your questions, send us your comments, even tell us where you're from. Tell us whether you like Kubernetes, whether you like Lambda, or maybe not. We're here to do everything, but yeah, let us know where you are, and remember we are live, so we'd love to see your questions and comments as well. Over you do, Christina.
All right. So I mentioned before I came to AWS, I did work for AWS customers, and last of which we managed Kubernetes. And we provided Kubernetes as a service to developers, which meant we provided all the whole pipeline. They could create, update, delete, deploy to these services many times a day. And that worked really well. Developers loved it. They had full control over the compute they applied to Kubernetes. But when it came to other AWS resources, things looked a little different. They didn't have access to the AWS console, or like any users that when organizations grow, usually that access gets taken away. In the past, they might have. And we were a Terraform shop. So every time when a request came in, hey, that compute that we just deployed to Kubernetes, that needs usually state. Like I need a database, I need an S3 bucket, I need some resource, a queue if it's event-driven. Now I need something on the AWS side. Well, then they had to open a ticket, and a platform engineer would pick that ticket up, do some Terraform and apply it, and then you get the resource, and there's some back and forth. Well, our developers wanted to use Lambda as well, because some workloads are just better suited for Lambda. For serverless, and they wanted to build a few types of serverless architectures. Well, at that situation, we were not going to go for SAM. We just didn't have the knowledge in-house to do it, and we already had one infrastructure as code, one process, two processes that were vetted by security, compliance, yada, yada, yada. So we were like, okay, we'll just utilize the Terraform one. Well, that created more issues than it solved, because with Lambda, usually there is more than just a function. You need a way to trigger it. You need somewhere to put in the results. You need more than that. So in that ticket, there was a lot of back and forth. I used to not like these tickets when I got them, because it's always like, how are you going to trigger your Lambda? There was like, it would take more than a week on just the back and forth. You don't have, like, it slows development down. It's not good for either side. There was a period of time where we tried to open Terraform tooling to developers. In that situation, they were not very excited about learning new tool and HCL and so on. So when I came to AWS, I found out, I started talking to customers, and I found out this is not a unique situation. A lot of companies that already utilize Kubernetes and build the authentication, the compliance, like everything around it, they want to use serverless too. They both complement each other. There are some workloads that are better suited to run this compute on Kubernetes, but there's some that are better suited on Lambda. And this story repeated itself in different ways, shapes, or forms, but slightly different. Maybe you have a slightly different story, but it's kind of the same thing. You know, some companies did use CloudFormation. Some other ones were successful in removing the ticketing system. Some even have whole teams of platform engineers that are building and updating this bespoke in-house built platform to do this. But when I came here, I found about like products that extend the Kubernetes API so that we can reuse that Kubernetes pipeline to do the exact same thing, to just extend it to deploy AWS resources, including Lambda and everything that it needs to trigger it. And one of those projects is Crossplane. And what Crossplane does, it's literally translates the Kubernetes API into AWS APIs amongst a lot of other APIs.
Christina, that's interesting, as you mentioning the APIs, that sometimes, there are different kind of parts to Kubernetes as there are different parts to AWS. And you've mentioned the Kubernetes as an API, but also Kubernetes can obviously run workloads itself. It is a container orchestrator, and it is going to send networking traffic or HTTP traffic or any kind of traffic to a particular pod on a bunch of hosts. How should people think about the Kubernetes API, which Crossplane is interacting with, and then the sort of data plane operations when Kubernetes is spinning up containers and routing traffic between them?
Mm-hmm. So Kubernetes, as long as we've known it, came as a container orchestrator. Its job was to orchestrate containers for as long as we know. And now we built this pipeline around it. And now we found out that it does the authentication well. It has integrated RBAC mechanism. It has admission controls. It plugs other open source software such as Open Policy Agent and Gatekeeper, and you can do policy as a code and apply compliance with it. And then that just extends, not only extends, but now we're starting to think about Kubernetes as this ecosystem that we can build a platform upon. It has like all the necessary components for a platform.
And I love that distinction, the way you explain it as well, rather than, because when people even talk about, Kubernetes is a container orchestrator, I think they're missing a lot of the story, because it's not just about putting pods and putting containers on different compute hosts. It is all of that ecosystem around with the authentication, all the RBAC and all that kind of thing. And if you standardized on that tooling, I can appreciate that AWS can maybe, and especially the serverless services, can be a bit of a blocker to what you use, because hang on, SQS, Lambda function, that's a different API. How am I going to do all of this? And I think in the Kubernetes world, you do have a difference between often what your developers are working on and what your platform team is working on, which is maintaining the platform, which is Kubernetes and the integrations and the RBAC and the controls and everything. So I love this better together story. And for me as well, all the serverless services we know and love, to be able to have a whole different ecosystem that can also use them is super powerful. So yeah, I love it.
Yeah. So just to add to that is customers sometimes ask me, when would you do this? When would you use Kubernetes to deploy Lambda? And there is a few distinctions here. The first one, you have to know Kubernetes or willing to learn it to greater extents to a 400 level. Yeah. So usually at this time, customers who reach out to and need help with this are customers who are at like a 300-400 level Kubernetes. They run it in production. They have the compliance, that they have already built the pipeline. They have observability, Like they have a very strong foundation. There's an emerging trend where customers want to start using it, but they don't have the foundation, which is completely okay. We'll help you build it one way or the other. But just to say the distinction, it's like customers who are already deep in the woods with Kubernetes and they want to complement it with Lambda, but not only Lambda, they want to extend it as a platform that encompasses almost like any AWS resource and give that power to the developer to be able to control that and put some guardrails around it in a controlled fashion. That's when you do it.
Okay, no, I like that distinction. So this is for Kubernetes customers who running it in production are comfortable with Kubernetes or proficient with Kubernetes, but instead of having to run your own compute instances or your own message queue, for example, why not use SQS? Why not use Lambda? Why not use the infinite storage of S3 and use those services that AWS provides, but have a bridge between the two systems? And so you get the best of both worlds, your established platform that your platform owners are using, but a lot of the undifferentiated heavy lifting of running a compute runtime and a message queue, you can offload to AWS. But importantly, the way you interact, that just all looks like Kubernetes. And so your developers are not having to learn a whole bunch of new tooling and a whole bunch of new practices.
Exactly. So now if I have my Kubernetes cluster and everything around it with the tooling, with the compliance, yada, 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 I just put Crossplane on it, for example, and then I can do all that. So now I'm going to switch to the demo, but in the Crossplane world, what you do is you would use the exact same tooling. You check in your code in Git. In this case, we'll use Argo CD, which is a very common CD pipeline to deploy to Kubernetes. But this is just like any pipeline. I want to stress here, any pipeline that you're using that can deploy YAMLs to Kubernetes, you can use it. It doesn't have to be Argo CD. It just has a nice UI, and it's good for demos. So the first thing that we're going to do is take a look at the developer interface. That is the key point. So the developer interface consists of a YAML file, a Kubernetes YAML file called a claim. And I'm going to switch to my VS Code now. So this is the developer interface, and let's take a look at what's in here. It's the developer code, the application. In this case, we have a Golang app. And alongside the application, we have this folder called a claim. And in the claim, we have, as I mentioned, Kubernetes YAML file. So this is of a kind serverless app. We'll talk what that means later. And here we have we have a name and we have an image name. So in this case, our code, we have a GitHub Actions pipeline that is going to come here and build a Docker container behind the scenes, and it's going to push it to ECR. And over here, we're going to say, this is the image name that we're going to build, and we will have a version to deploy. And in this case, we have exposed the memory size. And I exposed the memory size on purpose because usually when developers deploy Lambda, they will deploy it with the default memory, or the platform team will deploy it with the default memory. And the first ticket afterwards we would get
more memory, please.
Can you bump my memory? So I put this here on purpose. And that's it. That is the serverless app. So let's see what happens. I said I'm using Argo CD. So I did prepare an Argo CD app here that would just deploy that claim using Argo CD. I'm just gonna apply that Argo CD to Kubernetes.
Is your K a shortcut for kubectl? Is
that yes, K is shortcut for kubectl. And there is our Lambda application. So this is the Argo CD interface, and we'll go in here. So this whole architecture takes good maybe 6 minutes to come up because it does create all the AWS resources, all the linking in between the resources. So I had it ready and deployed just to be cautious of time
So
here.
think of this like the cooking show. When there are two different ovens, something goes in the oven, and then the second oven is already prepared,
Yes.
just to save the time.
Yes, this oven has been prepared. And in addition to that, I am using a special Argo CD configuration to just show me what I want to see. Okay. So let's see what got deployed here. This simple claim file, claim YAML, deployed a serverless app, and here are the building blocks. So let me see if I can make this a little bit, nope, bigger. Okay. So we're going to look at this row over here. So we'll see the event source mapping, the IAM policies, another IAM policy, the Lambda function, the object storage, and the queue, the SQS queue. So it did create a lot of resources. It did link them together. And if we go back to the diagram, I know this is just 3 resources here we have, but the links in between them and passing errands, and it is not as simple as it looks. And we did that with where's my claim? Look at that claim. If I'm a developer, I'm gonna love this. There is no cognitive load. I just give it, here is my image, here is the version I want to deploy, and here's my memory size. Those are the only thing I have to pass in order to get the whole shebang.
So it's like a pre-created pattern that in effect you can do, and your developer only needs to see the sort of Lambda part of it with a memory size configuration, and the fact that there's a queue and a DynamoDB table is sort of abstracted from an infrastructure provisioning point of view.
Exactly. Exactly. So it is completely abstracted. They don't have to worry about it or any of that. So the first thing we talked about the developer interface is a developer can create. They can create this abstraction of a serverless architecture. The second thing they want to do, as we talked about those tickets, is they might want to change something. So in this case, we're going to go ahead and we're going to change the memory. Okay. Whoops. Okay, and we're gonna commit that change. Okay. All right. Okay. Did I commit it? Did I push it?
Yeah, I thought you did. One of the songs a
I didn't
little bit slow.
commit message. That was the updating memory. Let's try that. See if it works. All right.
Ah, there we go.
That's better. Okay. So now I pushed this change to my Git repo. Where is my Argo CD? And Argo CD will pull the change. So usually Argo CD is a GitOps tool, and GitOps means that it would automatically reconcile it. Because this is a demo, I specifically have it not set to do that. So I have to click the buttons. Usually this, depending on how you set it, this would happen automatically. But because I want to show it, I made it like this so we can see the diff. So the diff here is the memory size is, I'm changing from 128 and to 256. And I'm going to check my Lambda function here at the AWS console to make sure. So right now the memory is 128.
It's interesting, even looking at that diff where you had before, you can see actually all their configuration information,
Yes.
which is in there, but all of that is not actually provided to the developer because they don't need to see that. They don't need to the ARNs and the encryption policy for SQS or S3, for example.
Yes. So now we are going to go ahead and sync that change and see what happens. And now I'm crossing my fingers that it's all going to work. It's usually, it does have some, sometimes the system is shy. And let's see. So now we're going to go and take a look at this function. And with Crossplane, you check the events. And there's an event that last occurred 1 minute ago. Maybe there will be another one shortly here. But let's go and all right, let's go and refresh, see what happened here. All right, we're still at 128. So how Crossplane works behind the scenes, it has
there we go. At the top, you can see updating the function. So that's the API call that's then whirring in the background.
Yeah. So it has a reconciliation loop. So it's not going to update it right away. It's going to do it on the next reconciliation loop. And now it's updating it. Okay. Well, give it a moment. There we go. Let's see what happened now. Nope. Huh.
Not today.
Not today. All right. Okay. Why are we misbehaving here? Well, it says 2 minutes ago, so I did put the change less than a minute ago. Let's see if I sync this resource. Is it going to pull up something? Okay. Oh, you know what we can do? I will do the following. So I haven't done this in a demo. I'll double check here, but I'm going to do the following. I'm going to go ahead and let's see. All right, still not there. So I'm going to try to delete this function. So what is supposed to happen when I delete? I did type deleting a function from, okay. Did I delete it?
Yeah, that's gone. That's gone, yeah.
It's gone. Okay, look at that. 8 seconds ago. It just reappeared again.
Wow, so that's really quick. So, that's one of the powers of Kubernetes is the maintaining of the state. Actually, maintaining the state is the wrong way to talk about it, but the maintaining of your infrastructure. Something goes wrong, the idea is, a pod dies or something goes down, and Kubernetes is just going to rectify it and fix it. And it is interesting to think that, well, yes, when you delete a Lambda function, then Kubernetes is going to go, oh, Lambda function no longer exists, and just recreate the Lambda function, creating that state in a way.
All right. Let's see. So now we're going to go through this thing. Decide. I clicked the button to replace it. So now it's going to go and create us a brand new Lambda function because my memory, I did test this yesterday and it worked just fine.
Of course, this is live demos. This is what happens,
Yes, live demos. This is what happens. So it's creating the whole infrastructure. It's creating the queue right now. And then we can see it like resource by resource.
So when it's doing an update like this, does it delete the existing resources, or does it do a diff, see what's different? Because for example, updating the queue, is it actually updating the queue, or is that the sort of Lambda event source mapping that is talking to that queue, or what's the basically what is it updating in this scenario where just a Lambda function has been deleted and needs to be recreated?
So when you delete just the Lambda function, how I did through the AWS API, or change anything with it, it would go and recreate it just the same way. It's even going to use the same name and all the parameters. It's going to recreate it the exact same way. So what I did right now is I thought Argo CD is not propagating the change in some way, shape, or form. So I clicked the button. When I put a sync here, I said replace.
Okay.
Yep. This is an Argo CD function where it's going to go and replace it. So now it's creating me a brand new Lambda function with everything. And I'm assuming it's going to remove the old one. And it created me everything like from scratch, so to speak. So now my Lambda function is ready and I should see it. And it won't be this one. It will be, let's refresh. There it is. There's the new one, 37 seconds ago. And let's see. Well, this time it's 256. All right. So another thing developers need to do is also update their code. So let's go to the application over here, to the code. And we're not going to do anything fancy. We're going to just remove a few empty lines to imitate a change. So I'm going to save this, and this time I'm going to put a commit message. And sync it. So after this change syncs to GitHub, we have a GitHub Actions trigger that knows that there was a change to my app directory. So then I'm going to go and build a new image. And see here, I have this version as 5.13. Let's go back here and see the image. So the image is 5.13. So what I'm expecting to happen right now is this GitHub action builds a new image. It calls it Lambda test. It tags it with 5.14 incrementally and pushes it to ECR. And then it's going to come back here. Well, not here in my VS Code, but here in this file in GitHub action. And it's going to update this version here. It's going to bump the version in the file, and it's going to commit it back to GitHub. And that way, when I go to Argo CD, I'm going to see the changes over there. So let's go and check on this GitHub action if it's ready. It is still running. And now it's ready. That means here, if I go and see the live claim, 5.14, and my VS Code would still have 5.13. So now if I go to Argo CD, which is still working on, now it's ready. Okay, so now if I refresh Argo CD, there we go. I see there was a change, and let's check what that change is. And we're going to take a look at the diff here. There we go. We want to update the image from 5.13 to 5.14. Yes, that is what I wanted. So please go ahead and work this time. And see how it flickered? I don't know if you noticed that, but there was like a tiny bit of flicker. Hopefully that meant 5 seconds ago, it says successfully requested update of external resource. By the way, these red messages here, when the function is creating, we just recreated it, they were because we were waiting on resources to come up. We're waiting on the role to come up. So when we're creating, these are totally normal. And right now, let's go and take a look at this and see. And we have 5.14. Awesome. Cool. So if I'm a developer, this is the things I need to do. And I could do them very simple. There's like zero cognitive load, additional cognitive load. Like I have, like if I go and delete this this claim, I have control over the full life cycle of the serverless architecture. I can create it, I can update it, I can push code to it, I can delete the whole thing if I wanted to.
And as a developer, everything you're looking at is literally within your VS Code terminal using kubectl, all your Kubernetes native tooling. In fact, you don't even really need to go to the Lambda rescues or even the AWS console at all. Yes, you're probably going to go to your Argo CD console just to monitor your pipeline if you need to, but that's a secondary step. And again, Argo CD is all going to be within your Kubernetes ecosystem. You're not having to learn these other tools.
Yes, and in this case, developers can have access over the like read access to the AWS console, which enterprises would allow, and they can go and see. What they shouldn't have is write access, or nobody should. But let's be honest, sometimes if it's in the middle of the night and I got paged and this Lambda needed more memory and it's 2 a.m.
Sometimes you're going to take a shortcut. Yeah.
I'll take the shortcut. I'll do this, right? And I'm going to save it. Well, right now it's 5:12. But what I'm expecting to do now is Crossplane on the next reconciliation loop. It's going to come here. That was my update. On the next reconciliation loop, it's going to detect there's a change, and it's going to put it back into place. Let's see. Well, it's going to take,
on the next loop,
on the next thing.
But this highlights the sort of the compliance aspect of Kubernetes, that it's just going to, whatever you do, you can try and break it in the back end, increase memory, do a quick fix, and to keep your GitOps workflow in sync and everything audited, it's just going to set it back to what it needs to be in source control.
Yes, it gets GitOps all the way to your application and to your infrastructure.
Now, Christina, when you were looking at the Go code that you just removed some lines from me looking at that, there was nothing Lambda specific about that code. There was nothing I saw about, how that's actually going to be packaged in an image which Lambda is going to be able to use. Is that also all just abstracted from the developer? They can concentrate on their Go code, and the actual packing of the image and uploading that to ECR is also just handled by the platform. And then obviously Lambda is going to pull that image from ECR to create the Lambda function. But there seemed to be very little even knowledge of Lambda and the runtime interface clients and all the bits you need in a Lambda function for it to work, other than your application code.
Usually a platform team would scaffold this repo out.
Okay, yeah.
That's what I've seen, where it does come with the pipeline, with the GitHub Actions or the Argo app, whatnot. It depends on the platform team, but usually that with like a basic scaffolding of what this enterprise service looks like, because even with Go, you might have like some custom code that is boilerplate, so it's going to be there, and so on. So usually that is provided. There is a new tool, another open source project, Backstage, that works really well for scaffolding that out. Nice. I'll add it to the demo next time. We'll scaffold out everything with Backstage.
But then would the developers then edit the Docker file here at all, or would that also be part of what the platform team would scaffold? Because that's very, you can see how little that Docker file is. It's basically just copying your main Go binary into the Lambda task roots. That's as simple as a Docker file for a Lambda function can be, really, which I think is powerful.
Yes. Absolutely. I think it's going to be, in my opinion, it should be scaffolded out. This whole repo should be scaffolded out. Developers should have even the claim scaffolded out. And the thing that they need to worry about is the code. That is what we're trying to convey here. All right. So where do we go next? Let's double check here. Hopefully this time around is nope, still there. Okay. We'll try it in a little bit. Usually it's 10 minutes. It's been 5 minutes. The default for Crossplane, I believe, is 10 minutes.
So,
Okay, so in the meantime, while we wait for this, we are going to take a look. So now we talked a lot about the developer interface and how amazing it is for developers to use this and how easy it is and so on. So this is a relatively complex architecture. So for all that complexity to work, somebody has to do the heavy lifting. Right? In this case, the platform team is responsible for setting up Crossplane, giving it the proper permissions, and setting up all the other resources for this claim to know what to do when it's applied, once it's applied to the server. Right now, we have separated our compositions. Crossplane composition is just a template, like a blueprint of what needs to happen. So the compositions are set in like two-tiered architecture. There is the base tier architecture that has the building blocks, and that is the SQS queue, the Lambda function, the S3 bucket, and everything that they need to connect to each other and talk to each other. In addition to that, they have the defaults, some defaults that are not exposed via the claim to the developer. For example, the SQS queue is encrypted by default. So we have some security embedded in this, that the S3 bucket has public access turned off by default. It also is encrypted by default, and all the connective tissue. And then we have a top-level composition, a top-level blueprint that pulls all the other ones together and just passes a few ARNs. So when the S3 bucket is up, it's going to put the ARN in a IAM policy so the Lambda can talk to the S3 bucket, things like that.
Does Crossplane use CloudFormation under the hood, or is it just calling the AWS API directly to create all these services?
So Crossplane, when you go to Crossplane and you want to connect it with AWS, there are two providers that you can use. One is the AWS provider, and it's very confusing, so I'm glad you asked. One is the AWS provider. The AWS provider hits the API directly.
Okay.
It does, I think some of the resource, I'm not sure, maybe some resources use CloudFormation. I'm not 100% sure on that, but some resources hit the API directly. It is faster, for sure, than the official provider that we're going to talk about. However, it does support less resources. And then there is the official provider. And with the official provider, what it does under the hood, it uses Terraform. But like you don't see any Terraform. Under the hood is Terraform. You would never know. Even if you're a platform operator, sometimes you don't even need to touch Terraform. We're going to take a deeper look of what these compositions look like. It's just YAML.
Okay, yeah.
Unless you know it's Terraform, maybe you won't find out it's Terraform.
Okay, yeah.
So it does use Terraform. Lately, this one supports almost everything that Terraform supports. It has a broader range of AWS resources. As of a month ago, when you install it, it installed 900 custom resource definitions, 900 CRDs to your cluster. And depending on the version of the cluster and the other things, sometimes there was an issue a while back that they fixed, but not all the libraries have it. Not all the tooling has it just yet. Like everything has to be up to date. Sometimes it would slow your cluster down. So what the official provider did is they did what's called the provider families, that they split up that provider. So now into smaller providers. So now if you just need IAM, S3, Lambda, and SQS, you can grab those providers and you'll have 200 CRDs, not 900, and your cluster is going to behave okay. Okay, so let's take a look at those compositions here, and I'll go. So this example, first and foremost, this example is in our Crossplane or EKS repository, and there is in the README there is step-by-step guide you can follow along. You have to do the prerequisites.
Yeah,
So,
I'll post that doc link. I'll post that link in the chat so you can get straight to the repo.
yeah. So here, let's navigate into the compositions folder and take a look at our serverless composition. So those building blocks, those compositions, they were a combination of an XRD and a composition. So the XRD stands for Composite Resource Definition, and this tells you what your claim looks like. So in this case, we had exposed image name in the claim. We also had memory size. It seems like we can also pass it environment variables if we wanted to. Also, this claim, you can actually decide whether to use a container or a zip file because it supports both. You might want it to use a zip file and push it to S3. And in that case, you're going to give it the bucket name, a bucket key, and a handler for the language that your zip file, like in this case, it would be Go.
Christina, these compositions, just jump in, how are these compositions different from the blueprints? Do you then create the blueprints based on the compositions? Are these the compositions that AWS or the provider provides that you can then scaffold your application and then you build your blueprints on top of that? Or am I completely mixing it up, which is entirely possible?
So when you install Crossplane, what it provides is managed resources and the ability to create XRDs and compositions. So managed resources, like I can create a single Lambda. I can give it my YAML file, and it's going to give me a single Lambda. But once you start creating more than just one resource, and you want to pass some errands, and you do want to add abstractions on top of it, then the platform team needs to create those couples of composite resource definition and a composition. So the composite resource definition will tell you what the claim looks like. What can you pass into the claim? And then the composition, which is this one, is going to tell you that that's the template of what's going to happen once you create a claim, essentially.
Okay.
Yeah. So once you create the claim, it's going to get you the SQS. And this is the SQS AWS blueprint one. So this is the abstraction, how the abstraction layer goes. This is the top level composition, and it's going to refer to an SQSQ composition that would then create the SQSQ. We can look into that one too. But this is going to create the SQSQ, the event source mapping, the Lambda function, and the bucket, and some IAM policies. And then, for example, if we take a look at the SQSQ and that blueprint of what it's going to be created, it is a queue. And then here we're going to say you're going to encrypt this queue and so on. So this is literally, I know it's a lot of YAML when I scroll up and down. I do realize that. But it's also, once you get used to it,
but this is exposing the richness of the functionality that AWS is providing. So there are a lot of options here because there are a lot of cool things that you can set. So if you want the functionality, it's all over here. But as you say, by the time it gets to the end state where the developer is interacting with this, a lot of this is abstracted away, and your platform team can deal with the defaults. Set the encryption level, set the S3 buckets, public buckets off, and done. But I mean, it's a lot of LAML because there's a lot of things you can set.
Yes, absolutely. And over here, I saw a message that 4 minutes ago, it requested update to the external resource. So if we go back and you remember how we changed.
Everybody hold thumbs. Everybody hold thumbs.
Yes, please. All right.
Yes, we're done. Winner.
Okay, this part worked.
Cool.
Okay, and with that, I think that concludes the demo part. So now, Julian, do you have any questions?
We do have some questions, but just before we do get to, well, first of all, thank you for the awesome demo. I like this sort of three-part of looking at the developer perspective of it, which we started, where the developers actually got very little to interact with, but they've got the power to set the memory. They can do their code. I was impressed with how even the way the Lambda function is built, even though you could look at the Docker file, it just all happens. It gets uploaded to ECR. Lambda's going to pull that image from ECR and run your Lambda function. Upgrade your memory. So literally just a git push, that powerful git ops mentality, which is powerful in Kubernetes, and off that does. And then just flipping it around and seeing the power of what the platform team has control over. All, as you show there, all the things that they can configure, they can stitch these services together, because these are architectural patterns. These are powerful architectural patterns. To have an SQS queue, which can act as a buffer, messages can be stored there. You can use it for rate limiting. You can use it for a whole cool bunch of stuff. And then a Lambda function is going to consume that and write to S3. And the platform team can literally create these little mini packages, which they can expose to the developers. And the developer in a few lines of YAML can just consume that. And the third part, which is the big Kubernetes thing, is also the drift detection, because you change something. I mean, even deleting a whole Lambda function, just gets recreated behind the scenes, and hopefully nobody was none the wiser. So I love the sort of three different use case stories and how they interact with each other. But in terms of questions and comments, well, Aaron Hunter, thanks so much for joining us via Twitch. Lambda EKS in Crossplane, lots of ways, I like it. Aaron's too smart as well. He was thinking and he was listening. And did Christina just say pass ARNs? What? No, ARNs. So,
sorry.
Aaron, do you come on every stream and talk about Aaron and ARNs? I would do the same. So thank you. It made me chuckle. So thank you for that. But then Sushant Patil, thanks Sushant for joining us via YouTube. Is there any way to see additional things like invoking a Lambda function, looking at the logs related to the run of the Lambda functions, maybe any metrics that are viewable under any Kubernetes add-ons? So I suppose that the bigger question, the bigger picture of that question is, yes, a Lambda function runs and it runs logs. Is there any sort of way back into the Kubernetes ecosystem that you can view any of those kind of logs? And then, how would somebody think about, metrics? I know, things like Prometheus and everything to do with the Kubernetes world. So, logs and metrics. How would people think about this in this approach?
So logs and metrics. Logs, usually Lambda by default, you would send your logs to CloudWatch logs, and CloudWatch does integrate with Prometheus, so you can kind of integrate it back from the CloudWatch perspective. You wouldn't push back the logs into Kubernetes and then grab them from Kubernetes. Depending, so one question was logs. The other one is metrics, the exact same thing. Invoking the Lambda function. For invoking the Lambda function, right now it's invoked by the messages you push to the queue, some application that pushes messages to the queue. If developers want to invoke the Lambda function just to test it, we've seen giving them access via the AWS console to invoke it, not through Kubernetes.
Okay, that sounds good. And also remember, with things like Lambda, Lambda's got a lot of integration with a lot of different things. So for example, Lambda has the telemetry API, and this is an API for grabbing telemetry from a Lambda function invoke, and you can get logs, and you can get metrics, and you can get traces, and then you can literally send it absolutely anywhere. So you could send it back into your third-party tooling, you could send it back into your whatever you're using for your Kubernetes tooling. You can send it back on-prem, whatever. It's literally a TCP or an HTTP call. So, Lambda is really flexible with that kind of thing of getting your logs out. Yes, of course, you can send it to CloudWatch. CloudWatch then has integrations with Prometheus and other things as well. But also you can just send logs directly from Lambda to a whole bunch of different kind of services. So that is a useful sort of integration to potentially look at. It's called the Telemetry API if you haven't used that before. Well, thank you, Sushan, for that question. Slightly actually different to what we're talking about today, but I may as well cover it. Shiva Gaming, thanks so much for sticking around. You did ask your question much earlier and we didn't get to it. Just a Lambda layer support in the CDK. Yes, you can build Lambda layers in the CDK. I just did find a link for that, so I'll put that up on the screen as well. So yeah, the CDK Cloud Development Kit, where did we have it? Lambda, so that's the link. A bit much to read, so maybe if you're watching afterwards, you can hit that pause button and type in the link, or you've got a clever screen reader. But yeah, you can definitely create Lambda layers using the CDK. I think that's what we had for questions. Did I miss anything? If anybody else has any questions, please send them our way, and we'll be happy to do that. So just going on, Christina, where do you see people going from here? You've created an application here that was sort of SQS and Lambda and S3. What other kind of use cases can you think of? And just to expand as well, in fact, we've talked about SQS and Lambda here as well, but I know there are other integrations with AWS services. For example, you can use the AWS controllers for Kubernetes to also create Lambda functions, to create event bridge event buses. So yeah, Crossplane is one way to interact with AWS API, but the AWS controllers for Kubernetes is also another whole way. So yeah,
Yes,
different way, shapes, and forms.
I do get this question a lot. Why are we using Crossplane as a third-party product or an open source project where we have AWS controllers for Kubernetes, which is also open source? And there is AWS controllers for Kubernetes. You can create Lambda functions. Yes, absolutely. The difference here is when you want to create something simple, you can create it. But if you want that connective tissue in terms of passing ARNs around, ACK doesn't support it out of the box. It doesn't have the notion of composition. So there is a way to do it. You just have to do it yourself. Like you have to program it yourself, like drop it in the config map, pick it up from there, from the next resource, and so on. So when you're trying to do an architecture, it is a little bit easier with Crossplane of what it provides out of the box. With that said, ACK does have enterprise support for the GA controllers, meaning that if anything goes wrong, you can reach to AWS and you have enterprise support. You can reach out to AWS with a support ticket. We're going to help you out. With Crossplane, however, it's an open source project. We don't own it. If you need support, we have a few ways that we help you. We still help you out with that. We can consult on how you set it up, how you structure it, and so on. We have AWS ProServe that can help you build the compositions and the hands-on deck if you need them. And then we can connect you with our partners at Upbound who provide enterprise support and can provide support if you do need that support. So very important distinctions there.
And also you may be using Crossplane with other providers for a whole bunch of other kind of things. So if you're already using Crossplane, this is an easy fit. You're not then having to try and understand how the AWS controllers for Kubernetes works. You've got Crossplane already, plug it into Lambda, off you go. So before we say goodbye to Christina with her awesome demo and information, let's just talk about next week on Serverless Office Hours. Next week, that didn't quite appear. We have Alan Helton, the one and only serverless hero, Alan Helton, who's going to be talking about serverless real-time communication with Memento. And Memento is a super cool company. They have a caching service and more. They had MementoCon this week. And so Alan Helton is going to be joining us as a guest next week to talk about all real-time communications, caching, queuing, and other kind of services that Memento does. That'll be same time, same place next week. Of course, the buttons are not clicking. I'm also having demo issues. Don't forget serverlessland.com, everything to do with serverless on AWS, plenty of blogs, more learning guides, more information being added literally nearly every day. Lots of patterns as well. Also, if you are a Terraform user and want to build serverless applications, click on the code and the patterns and you can filter by Terraform. and build a lot of your serverless apps with Terraform as well. The new learning guide, EDA Day Nashville on the 26th of October. And there we go. That's the code, step functions, workflows, some snippets, and a whole bunch of repos. So lots of stuff on serverlessland.com. Really one-stop shop to be able to get loads of information that you can on all things to do with serverless. But Christina, we really appreciate you taking the time to join us here on Serverless Office Hours this week. Hope to have you back another time. And thanks so much for bringing Lambda and Kubernetes and Crossplane all together with a cool demo and showing us all the cool stuff that's possible. Thank you very much.
Thank you so much. It was so much fun to be able to go in a little bit more depth with the whole hour.
Perfectly.
I had fun. Yes. Thank you so much.
And everybody else, thanks so much for watching, and we'll see you same time, same place next